In this lesson, we're going to be finding the gradient of a straight line. So here's our straight line on the diagram there. And to find the gradient, we need to understand what gradient means. And gradient means the steepness of the line. And it's measured by a change in the y direction divided by a change in the x direction between any 2 points on the line. Let's look at this further within the example. Let's pick 2 points on the line. So that point there has a coordinate -3, -3. And the second point on the line, well, that has a coordinate of 1, 5. So to get from our first coordinate to our second coordinate, in the y direction, we have to go upwards 8 units. And then across in the x direction, we have to go across 4 units. So the gradient, it tells us, is the change in the y direction. So the change in the y direction between those 2 points was +8. So that's a change of 8 divided by a change in the x direction. And the change in the x direction, as we can see on the diagram, that was a change of 4 units. So the gradient is 8 divided by 4, and that equals 2. A positive gradient, such as 2, means the line slopes upwards from left to right. So we would always start with our leftmost point going to our rightmost point, and to get from our leftmost point to our rightmost point, you can see the line is sloping upwards. Here's our second example. Once again, we pick 2 coordinates on the line. That coordinate there is -3, -7. And our second coordinate is the point 1, 5. To get from our first point to our second point, in the y direction, we go up 12. And in the x direction, we go along 4. So the gradient is the change in the y direction, which from our diagram we can see was +12 because it was 12 upwards, divided by a change in the x direction, which from our diagram we could see was +4 because it was 4 to the right. And that gives us a gradient therefore of 12 divided by 4, which is 3. And once again, that's +3, and as we can see, the line slopes upwards from left to right. And here's a third example that I'll go through very quickly. The process is always the same. We pick 2 points on the line, and from our leftmost point to our rightmost point, we have to go upwards 7 units, along 14 units, and our gradient, remember, it's the y direction first, so that's 7 divided by the change in the x direction, which in this case was 14, and that gives us a gradient of a half. Note, the gradient is still positive, but the line is not as steep. Alright, the gradient of a half means it's not quite as steep as our previous 2 lines, which had gradients of 2 and 3. Now in this example, we've got a line that slopes downwards now, and because it slopes downwards, we should expect a negative gradient. We pick 2 points, that coordinate is -4, 6, and that point on the other end, that's the point 2, -6. To get from our first point to our second point in the y direction, this time we're having to go downwards, so that's -12. And in the x direction, we're going across to the right, so that's +6. So our gradient, change in the y direction, that's -12, divided by a change in the x direction, and that was +6. -12 divided by 6 gives us a gradient of -2. And that's what I said to expect. Because the line slopes downwards, that means it's a negative gradient. So we should look out for that when we see a downward sloping line to begin with, to straight away in our minds be thinking that must have a negative gradient. Here's another example. Excuse me. When we're picking our 2 points, we don't necessarily pick them right on the end of the line. We need to pick coordinates that are on whole number values in the x and y direction. So that's the point -4, 4, and to the right hand side of the line, that is the point 5, -2. To get from the first point to the second point in the y direction, I'm going downwards, so it's -6. In the x direction, it's to the right, so that's +9. The gradient, changing the y direction, -6, divided by changing the x direction, +9, and that leaves us with a gradient of -2/3. Once again, it's sloping downwards, so our gradient is negative.